All right, here is the key to the Ionic Compounds Practice. So the first one is done for you for the formula and the name. The second one, aluminum has a +3 charge, nitrogen has a -3 charge. Since the positive and negative charges are equal, you just need one aluminum and one nitrogen atom for that. If you look on the periodic table of ions in your yellow packet on page 3, aluminum, the name stays the same for positive ions. The negative ion, the ending of the word nitrogen changes to IDE. So the name for this one would be aluminum nitride. The next one, calcium, is +2, phosphorus is -3. So 2 and 3, to make those equal, 2 and 3 both multiply into 6. So if 6 is our total charge that we want, we would need 3 calcium atoms, because 3 times 2 would be 6. So calcium +2 +2 +2 would give you a total of 6. Phosphorus, for you to get a total of 6, you would need 2 phosphorus. So in our formula, we would need 3 calciums and 2 phosphorus atoms. So it'd be Ca3P2. The name for this one, calcium would stay the same. Phosphorus changes to phosphide. So it'd be calcium phosphide. And again, we get these from our yellow periodic table of ions, which is on page 3 of your yellow packet. The next example, zinc has a +2 charge, chlorine has a -1 charge. In order to make those charges equal and opposite, we would need 1 zinc ion and 2 chlorine ions. So the formula would be ZnCl2. And the name would be zinc chloride. The positive ion name stays the same. The negative ion changes from chlorine to chloride. And last but not least, Fe has a +3 charge and oxygen has a -2 charge. This will be similar to the calcium and phosphorus example above. So 3 and 2 both multiply into 6. So in order to get a total of 6 for the charges, iron would have to be, you'd have to have 2 iron atoms and 3 oxygen atoms. So the formula would be Fe2O3. If you look on your yellow periodic table of ions, iron can either be +3 or +2. We have to specify which one it is in the name. So because this iron example is +3, this name would have to be iron 3 oxide. This Roman numeral name represents the charge of the cation. And you only have to do it for those elements that are in the middle that have more than one charge. Hopefully this helps.